Okay, rational functions, oblique asymptotes. So we're going to have asymptotes. We're not just going to have horizontal asymptotes and vertical asymptotes anymore. We're also going to have these slant asymptotes that are lines. Okay, so when the degree of P of x, so the top, is exactly one more than the degree of Q of x, that's when we have a slant or an oblique asymptote. Okay, and it kind of looks like this picture that we have over to the right. Now, the equation of an oblique asymptote is y equals mx plus b, which is the quotient of P of x divided by Q of x, just ignoring the remainder. We just don't even deal with the remainder. And then you just use long division or synthetic division to divide P of x by Q of x. Write the equation of the oblique asymptote using the quotient, ignoring the remainder. So let's just go over division for a second, because we might have forgotten it's been a minute since we did this. So we have x squared minus x minus 14 divided by x plus 4. We can use synthetic division to do this. You can always use long division, but I'm going to use synthetic division because the leading coefficient of the denominator is 1. So if you remember, I'm going to put negative 4 on the outside because it's the opposite. Then on the inside, I have 1, negative 1, and negative 14 because they're the coefficients. Bring down the first number. So we have 1. Then multiply. 1 times negative 4 is negative 4. Add those. You get negative 5. Negative 5 times negative 4 is positive 20. Add those, and you get positive 6. But we're going to ignore the remainder, and the equation of my slant asymptote, or my oblique asymptote, is x minus 5. Okay? Let's do one more. So if we have 6x plus 4x minus 11 divided by 3x plus 2, we have to use long division for this one. So first you divide first with first. So I'm going to have 6x squared divided by 3x, which is 2x. That goes on top. Then you multiply to both terms. So 2x times 3x is 6x squared. 2x times 2 is 4x. Then you subtract and you change both signs. So that's going to be minus, I'll put them in parentheses, distribute that in. So that's minus 6x squared minus 4x. Those cancel. Those also cancel. Then you can bring down the next term. We get negative 11. And you repeat. But negative 11 cannot be divided by 3x. That's my remainder. So we're just going to ignore it. And my equation of that line is y equals 2x. Okay, so that's just long division. You guys should know that. So that was just kind of a little refresher. Pull out that yellow cardstock paper that I gave you guys to take home last time. And we're going to fill out this part of it. Okay, so the equation form, that's f of x equals p of x divided by q of x. Now, we write the function in factor form, simplify, and then we can find the x-intercepts by finding the zeros of p of x. So you set the top equal to 0. You can find the y-intercepts by plugging in 0 for all the x's. So you find f of 0. Vertical asymptote, find the zeros of q of x, so of the bottom, and that will give you the vertical asymptotes. Now for the horizontal asymptotes, if the degree of p is greater than the degree of q, there is no horizontal asymptote. If the degree of p is less than the degree of q, sorry, I'm struggling, then the asymptote is y equals 0. And then if the degree of p equals the degree of q, then y equals the leading coefficient of p of x over the leading coefficient of q of x. Okay, now slant asymptotes, the degree of p is 1 more than the degree of q. Then y equals mx plus b, and it's the quotient of p of x divided by q of x, ignoring the remainder. Okay, and then wholes are common factors in p of x and q of x, and those are written as a point. Okay? So keep this paper handy, it will help a bunch, and let's go back to our other notes now. We're going to do example E. So if we have x squared minus 9 over x, first, we're going to factor it. So x squared minus 9 factors to x minus 3, x plus 3. Now we're going to find the zeros of p of x. So that's going to be x minus 3 equals 0, x plus 3 equals 0. So x equals 3 and x equals negative 3. My x-intercepts are 3, 0, and negative 3, 0. Now my y-intercept, I'm going to plug in 0 to the function. So we have 0 minus 3 over 0 plus 3 over 0. Well, it cannot be divided by 0. You can't divide anything by 0. So then that's undefined, which means we just don't have a y-intercept. Okay. Vertical asymptotes. So at the bottom equal to 0. So we have x equals 0. Whoops, get out of here. So we have x equals 0. My vertical asymptote is x equals 0. Horizontal asymptote, the degree of p is greater than the degree of q. So there is no horizontal asymptote. There is a slant asymptote, though, because the degree of p is 1 more than the degree of q. So I'm going to divide, and I have to put the 0x in there because you have to have a placeholder, okay? So x squared divided by x is x. X times x is x squared. Subtract. Those cancel. Bring down the 0x. 0x divided by x is just 0. So my equation is y equals x. Okay? And there are no holes. So now let's just graph everything we know. So 3, 0, there's going to be a point right there. Negative 3, 0, there's a point right there. There's no y-intercept. My vertical asymptote is x equals 0, so that's that. There's no horizontal asymptote. And then my slant asymptote is y equals x, which is that line right there. Okay? Then to graph this, remember it always just goes along the asymptotes. So that's going to be the left side of the graph, maybe. And that's going to be the right side. Okay, now I can do my domain. So my domain, negative infinity to 0, 0 to infinity, because that's the x values. And range is negative infinity to positive infinity. Okay, let's do another one. So we have 2x squared minus 3x minus 20 over x plus 1. First, let's factor that, so that becomes x minus 4 and 2x plus 5 over x plus 1. Find the x-intercept, so I have x minus 4 equals 0, and 2x plus 5 equals 0. So x equals 4, and x equals negative 5 halves. So my x-intercepts are 4, 0, and negative 5 halves, 0. Now my y-intercepts, I'm going to plug 0 into the function. Well, all of those zeros cancel, and you're left with negative 20 over 1, which is negative 20. So my y-intercept is 0, negative 20. Vertical asymptote, x plus 1 equals 0, so x equals negative 1. Horizontal asymptote, none, because the degree on top is greater than the degree on bottom. But we do have a slant asymptote, so we're going to divide this. And I'm going to use synthetic division because the one on the bottom has a leading coefficient of 1. So this is going to be negative 1 on the outside, and then 2, negative 3, negative 20 inside. Bring down the 2. 2 times negative 1 is negative 2. Add that, you get negative 5. Negative 5 times negative 1 is 5. Add that, and that's negative 15. Okay, that cancels, and my slant asymptote is 2x minus 5. So that's y equals 2x minus 5. There's no holes because nothing canceled. Now let's just graph what we know. So my x-intercept's 4, 0, so there's that one. And negative 5 halves 0, which is negative 2.5. So right there. Y-intercept, that's going to be off the graph, so we can't graph that one. My vertical asymptote is x equals negative 1. So there's that. My slant asymptote is y equals 2x minus 5. Well, negative 5 is my place where it crosses the x-axis. Then it has a slope of 2, so I'm going to go up 2 over 1, draw that point, down 2 over 1, draw that point, and then that can graph my line for me. Okay, and then there's the left side of the graph, there's the right side of the graph. Cool. My domain here, negative infinity to 0, and then 0 to infinity. That's wrong. That should be negative infinity to, I'm going to put the range up there too. This should be negative infinity to negative 1, and then negative 1 to infinity. Okay, and then my range is negative infinity to positive infinity. Cool. We're going to skip example G. I don't know what this is doing. Pause. Yep, we're going to skip example G and let's go to example F. So first we got to factor this. So that factors, we can take out an x on top. So you get x and then x squared plus 3x minus 4 over x squared plus x minus 2. Factor that, so that's x plus 4, x minus 1, then x plus 2, x minus 1. Those x minus 1s cancel, and you're left with a whole at 1. We don't know the y value yet, but we know that the x value is going to be 1. So I'm just going to write that over on the wholes part. 1, and then I'm going to leave the right side blank for now, or the y-intercept, or the y blank. So that simplifies to x times x plus 4 over x plus 2. And then to find that whole, I'm going to plug 1 in to that simplified equation. So that's going to be 1 and then 1 plus 4 over 1 plus 2, which is 5 over 3. So that whole is at 1 and 5/3. And I think that's the easiest way to find the wholes is right when you cancel it, that's when you should go find the whole. Okay, now let's go through and find the x-intercept. So we have x equals 0 and x plus 4 equals 0. So that means x equals negative 4. So that's 0, 0, and negative 4, 0. Now my y-intercept, plug 0 in, and you just get 0. So the y-intercept is also 0, 0. Vertical asymptote, you have x plus 2 equals 0. So x equals negative 2. There's that vertical asymptote. Horizontal asymptote, the degree on top is greater than the degree on bottom, so there's none. My slant asymptote, if we multiply that in, you get x squared plus 4x over x plus 2. We can use synthetic division to divide this. Bring down the 1. 1 times negative 2 is negative 2. Alright, so skip example G, and let's go to example H. So first we're going to factor that. So you get x and then x squared plus 3x minus 4 over x squared plus x minus 2, which factors further to x plus 4x minus 1 and x plus 2x minus 1. Those x minus 1s cancel, which means there's going to be a whole at 1. We just need to figure out what the y value is. So that simplifies to x plus 4 over x plus 2. And I'm going to plug in 1 for my x's to find my whole. So that's 1 and then 1 plus 4 over 1 plus 2, which is 5/3. So there's the whole at 5/3. Okay, now my x-intercepts, we have x equals 0 and x plus 4 equals 0. So x equals negative 4 and x equals 0. So 0, 0, and negative 4, 0. Y-intercept, plug in 0 into the simplified equation, and you just get 0, so that's going to be 0, 0. Vertical asymptote, x plus 2 equals 0, which means x equals negative 2. Horizontal asymptote, the degree on top is greater than the degree on bottom, so there's no horizontal asymptote. There is a slant asymptote, though. So I'm just going to multiply that x back in to make this a little bit easier for myself. And I'm going to use synthetic division. Bring down the 1. 1 times negative 2 is negative 2. Add those, you get 2. 2 times negative 2 is negative 4. Add those, you get negative 4. That negative 4 cancels, though, because we're just ignoring the remainder. So then that's x plus 2. And my slant asymptote is y equals x plus 2. Now let's just graph everything we know. So we know that there's an x-intercept at 0, 0, and at negative 4, 0. Y-intercept at 0, 0, which is already there. Vertical asymptote at x equals negative 2. Slant asymptote at x plus 2. So I'm going to go up to 2. That's where it crosses the y-axis. And then we go up 1 over 1, down 1 over 1. And there's that slant asymptote. And then we also have a whole at 1 5/3. So that's about right there. There's the left side, and there's the right side. Okay, so my domain is negative infinity to negative 2, and then negative 2 to 1, and then 1 to infinity. My range is just negative infinity to positive infinity. Because even though there's a hole right there, on the left side of the graph, there's a point there. Okay? Remember to take the quiz. I will see you guys tomorrow.